down up against this face, and then the interface ports are on a different location. For the sensor, there are 3 main ports. There's the power source, and this takes 2 separate 5-volt inputs. One 5-volt input for the analog electronics and one 5-volt input for the digital electronics. This has 14-bit analog to digital converters, so with all systems that use a really high-resolution ADC system, it's pretty common to see the analog and digital power supplies separated for noise issues. Over here is a LEMO connector, which is the triggering and I/O. You can pull a pair of these low for remote triggering to trigger the capture remotely, and the other two will send back a signal saying it is capturing, or you can trigger the capture over software using the USB interface. So this will interface with the USB 2.0 with the computer system, and when this is in the unit, it'll just plug. It's just a ponytail, little pigtail, which plugs into the USB feed-through on this side. Now, when installed in the unit, let's see, here we are. I believe it was, looks like this. There we are. So this X-ray sensor unit would be here, and the X-rays coming through the carbon fiber window would just fall on the sensor. And the sensor has a cesium iodide deposition on top of a fiber optic plate on top of a CCD unit. There's also a grounding line which should be connected to the sensor for noise reduction. Then the sensor board is powered off of this power converter board. This seems to have been designed for multiple different types of sensors in the Faxitron system, but this just uses plus or minus 5 volts, so there are some unused pins. It takes basically 5 volts in to 2 separate DC-DC converters to isolate the 5-volt supplies from each other. The outputs from the DC to DC converters are higher than 5 volts. This is then regulated down to 5 volts with a pair of linear regulators, then goes through some filtering and out to the sensor panel. So basically what's happening here is it has the large switching power supply in the back, which is probably going to have more ripple. Has some ripple filtration here with the 3 capacitors. Then separates out the 2 supplies, isolates them from the input. Now the DC-DC converters are also switching power supplies. They also have some ripple, so they're adjusted higher than 5 volts and then regulated down to 5 volts with the linear regulators, which chop off all of that ripple. And then you have the further filtration with some capacitors on the output, and then there's fusing on the output, and it goes, and then it just sends the power to the sensor board.